Put these hold downs in the middle, that kind of holds down the center line of the board. So this is the display as it's running. This little orange thing right here is the actual cutter head. And so you can see all these paths that it generates, and this is a path that the tool is going to follow as it's driving around. And this is the G code over here. This is what it's actually going through. This file is like 8,000 lines long now. And so as it goes along, each one of these lines sends a movement command over to the cutting head. One of the problems we ran into was as it starts to drill down, as it makes its plunge into the material, the plastic tends to kind of fray off in little thin strings. And the strings would tend to wrap around the cutting head. And once they start to build up, as the cutter would start to drive around to cut out the profile, those little strings will start dragging on the surface, and that creates heat. And it also prevents the chips that are being cut from being ejected up out of the pocket. And so it creates a backup of plastic right there, which just causes more and more heat. And then eventually it gets hot enough to melt the plastic, and then it's just a runaway mess after that. So one of the ways we tried to avoid that was we make the drill holes now with several passes, so it actually makes a bunch of little small cuts as it goes down. It takes a little bit longer to do that, but because it's only plunging a short amount every time, the strings that come up off and they start to flail on the cutting head, they're a little bit shorter. And so that was a suggestion that we found on one of the web forums out there, and after trying it, it definitely helped a little bit. For the most part, I've been able to run it without having to babysit it too much now.